Guys, to finish off the few missing parts of the 2014 higher level short questions here. First off, a nice easy one here to start, and as I always said, start off with the easiest. So the rectangle goes in here. Watch out for the parallelogram and rhombus. So like a rhombus here is a parallelogram because the opposite sides are parallel. So pair of opposite sides, both parallel. But a rhombus, all four sides are also equal in length. Parallelogram, opposite sides equal, or sorry, opposite sides parallel. And finally, trapezium. One set of parallel opposite sides. You two done. Number 3 on angles. The external angle of a regular pentagon is 360 degrees divided by 5. 5 sides, 5 angles. That's 72 degrees here for this external A. If 72 is the external, then the remaining internal angle here is the balance of 180 minus 72, which is 108. And then all the internals are the same, so B is 108 degrees. And finally, the angle of any triangle drawn off this line here, going from point 1 to 2, the angle is going to be equal. So it's 46 above here, it's 46 out here. We had number 4, freehand sketched and shaded and a little bit of shadow. Number 5 is our rotation. Number 6 is the axonometric, with them all done. Number 7 is the auxiliary view. 8, freehand sketch. 9 there was our SolidWorks commands, so trim, mirror, extrude and fillet. Number 10 is my next one. Such a common question here. The 3D graphic shows a child's rocker. The base of the rocker is a semi-ellipse. The figure shows the location of the axis here, and the focal points of the semi-ellipse, and point P is a point in the curve. Determine the lengths of the major and minor axis and draw the semi-ellipse. Very, very common question. So look, I'll just start off with a theory that the focal distances added together is going to be equal the major axis. So I'll add my two focal distances, so from F to P, and I'll add F1 now in a sec. And I'll graphically add F1. Taking the length out to F1 and adding it on. My blue line's a little bit short. That blue line in total is the major axis. Now I want to know what is the diameter, I want to know the radius. So I'm going to bisect that blue line. And I bisect the blue line. That's what I get there. Get the center point right here. That is the center point of the blue line, and the blue line is the major. So there's my major radius. I can set it to the left, to the focal point, or to the right, to the end of the blue line. But that is my major auxiliary circle radius. The center is already given to me. And this time we're working down. While the major is still set, I can find the minor. There's two ways of finding the minor. We can use our construction of down to the circle, into the center and across, or half the major. Usually from the top of the minor gets us the focal point, and this time we flip it backwards. half the major from the focal point gets us the minor. So that right there is a point on the minor radius, or the minor auxiliary circle. And open up my compass from the centre of the ellipse out to that pink point. That is falling really close to the focal points now for me. And I'll go with it. Sliding set squares will be fine for this job. I'll set the angle of my axis line there of the major. I'll just move it up a little bit, and I'll start from there, and I'll go sliding sets. Just use my 45, basically like a T-square, to give me a horizontal position, and I'll just work out from there. This is one of those questions that probably would be easier to stick on the page and have the T-square handy, especially when it's upside down. Nevertheless, it'll work just fine if you have a steady hand and if the set squares don't slide. I'm going to add in colour here. You don't need to. No, I'm just going to do it so hopefully it keeps it nice and clear on the video. Where am I going with this? I'm going from the outside point to the low point, so it's wide on the major here, and the minor is down just there. I'm going to go parallel to the major there, or across, and I'll do this same from the external points on this curve here. And sorry, no, I've just made a mistake there. That should of course be up. It's going from here up. And of course I had to use a fine liner for that. So I'm going to go pick a different colour here. And I'm going up to the major. So I just started constructing a vertical ellipse instead of a horizontal. Up from the major, out from the minor. Now my projection hits the minor, we cross over. And where the red lines cross, we get points in the curve. It does tell us to draw, determine the length of the major and minor and draw the semi-ellipse. I have all my points now. But because it's a loose page, it makes it nice and handy. We can link through all the points. Keep the page moving if you feel like it, if you think it'll help you. Once it's lightly dropped in, just go over it, heavy in the profile. And that is that question answered. Determine the length of the major and minor, we have done, and draw the semi-ellipse is done. As I said, that is a very common question. Number 11 here. I've started this one during the class there. Number 11 is to find the centre of a circle when we're not given it, so I just drew two chords. So a random line there, AB, and a random line, CD, and now I'm going to go ahead and bisect those two chords. And the two bisectors will cross, giving me the centre point. I'm going to go quite large with this now, so I'm going to bisect AB here. Keep it set the very same and swing for me. That's a random setting, it does not matter what size you set that to. I'll stick with a light blue here, so we have a dark blue on the chord and a light blue bisector going from the points of intersection of the curves there. So that light blue line bisects, splits the line AB in half right through the centre at 90 degrees. Let's apply the same principle here to CD, starting at D, going more than halfway. Just don't get confused between your curves. You have four curves, but there's a pair related to one line and a pair related to the other line. This pink bisector here, pin your points if you want. that pink bisector, go straight through the center of the red line, and then just identify the point. Just identify that point so that an examiner will know that you haven't fluked your way there and you've actually constructed it and you know what you found. That's number 11. Number 12. Draw two axes of symmetry, and it was as simple as join the dots because it's perfectly symmetrical through the red horizontal axis and through the blue vertical axis. Number 13, 14 and 15. So 13, there's quite a bit of detail in that one. I'll just zoom in on that. Quite a bit of detail in that one now to see there. Everything projected up from plan and across from the end elevation. Bit of visualization involved as well there. Number 14, an enlargement. The figure shows the outline of a magnet. Draw a new magnet similar to the given, meaning same proportions, with a length of AB increased to AB1. So we're thinking of proportion and angle. Proportion and angle will remain the same, but sizes will change. Point A is going to be my fixed point, and everything goes from A out and expands, and this is our new key point here where B ends up. I'm going to take this point first. I'm going to expand from A through and out. This original object had a vertical edge here from B up, and the new object is going to have a vertical edge from B1 up. The point I just found is point 1, so it's now extended out to point 1. I'd like now maybe to just get the curve after. I'd love to have that center point number 2, would be very handy. I'd like to have this point here number 3, so I'm going to expand out those two as well. From A being the fixed point, out through 2, and from A out through 3. So everything is expanding from the fixed point A. What do I do this time? When I look at my original proportions from 1, it was horizontally across to 2 and across to 3. If it was originally horizontal, it's going to be horizontal again now. So I take horizontal, just using my sliding set squares, I go from 1 across to 2 and 3. So we're keeping the same angles, we're keeping the same proportions. That's the new number 2, that's the new number 3. Make sure you check your accuracy here now. If I'm swinging from 2 to 3, it should be hitting 1 perfectly. There's a chance, oh no, that's good there. There's a chance that you'd lose accuracy in the process of doing that enlargement. There we are, that's the arch over the top. Now look, there's loads of ways to do this. I suppose the easiest way is probably pick another point, so I'll just go with a different colour here. So I have A, B, 1, 2, 3, we'll call that just point 4 and 5. My green points, very little work involved this time. Point 4 is on the line 1, 2, 3. So from A through 4. And I could go from A through 5. I really don't need to, but I will anyway just for the sake of it. And just landed onto the relevant line again. So 4 was on the line from 1 to 2 to 3 on that line. So it's still on the line. So that should be number 4 right there. And then point 5 is going to be around to here. Once again, we'll grab the compass. Check it before you rotate. Distance from 2 to 4 should map around perfectly. And hit 5. It's quite good there now, I'm happy with that. Until the compass slipped. Final thing here. 4 goes vertically down and 5 goes vertically down, and we'll finish off the 2 feet of the object then. If you think that these are too short to line up with, then just line up with the border box at the side. Take 4 all the way down, take 5 all the way down. Now I can see now why they wanted us to colour or shade the new magnet. It's very hard to even see it there, to make out the detail and to make out the difference between the original and the new one. So adding in that shade, such a simple couple of marks that loads of people will forget. And that's an enlargement done on a figure. That's that one finished. So an enlargement of the original magnet, and now we have our new size. Final question here, number 15. I'll just fold the page over to bring it into shot. And a third year student was asked to present her daily routine for a typical school day, and the school results were sleep or rest for 12 hours, school for 6 hours, study for 4, and leisure for 2. So what we'll be looking at here is fitting this into the pie chart. So divide the given circle to represent this information graphically on a pie chart. And once again, as I've said every time, colour or shade being the one that a lot of people omit. Colour or shade the completed pie chart. So what we look at first of all is, as we know, 24 hours in a day. Does it all add up? 12 and 6 is 18, and 4 is 22, and 2 is 24. So out of a portion of 24 hours, if each one is a fraction of 24, we need to figure out what each one will be as a fraction of 360 degrees. So 12 out of 24 is a half. And multiply each one by 360 then. Okay, so 360 multiplied by all of this column that I'll just create here is going to be equal to 180 degrees. 11. 6 out of 24 is a quarter, and a quarter by 360 is 90. 4 out of 24 is a sixth, and a sixth of 360 is 60. And finally, 2 out of 24 is a twelfth, and a twelfth of 360 is 30. So if you don't know how to do those, or if you can't get them off the top of your head, you should have a calculator with you for working them out. I'm going to start off. Now I don't actually need to use sliding set squares or anything here really, but I'm still going to because I just like to keep it tidy. So I'll start off with a horizontal split straight through the object, and total circle is 360 degrees, which means if I go halfway I get 180. Oh, it is not good enough just to do that. That is not sufficient. It is also not sufficient. Let's say I have my other portions filled in. It's also not sufficient to just shade it in and say nothing about it. You could probably take a good guess that if you didn't even read this question, there's probably going to be, if you see a pie chart, there's probably going to be a portion that's a half, there's probably going to be a 30 degree section, just based on all recent questions, you probably get a lot of the sections correct, but you know, just to ensure that you're reading the questions and taking it in properly and evaluating and analysing it properly, that's actually not enough. So I have mapped out a portion and I have shaded it in. But what I have not done is completed what is a pie chart, and the pie chart should tell us what everything represents. So if you decide that sleep/rest goes in there, or another option, if you have clearly defined in different colours, is that the grey represents sleep rest there. So I can actually reference, I can either reference by text or by colour. Next, I need to plot out a 90, a 60 and a 30. In this case here, I get my 90 straight down. And like while I'm here, I might as well split up the remaining 90 into a 60 and a 30. So there's 30 right there. And I'm labelled, so the 90 degrees is school. The 60 degrees here is study. And the 30 degrees, the small portion, is leisure. And then using whatever colours you want, or just shading only if you feel like it. But if you're doing shading only, make sure you put the keywords in here. It would be sufficient to just do what I'm doing here without having the keyword inside, and cross-reference your colours left and right, so at least the examiner will definitely know you knew what you were doing. The study here, so 60 degree block. Which is 60, study here. And finally, in purple is leisure time. That's 2 hours here. That's that question complete and the whole paper complete. So take all points on board when you're doing your questions at home. There's the last 3 are orthographic, our enlargement and our pie chart.